Okay, so today's topic, as I said last week, because I did tell you guys last week, you guys are going to be learning how to program the database starting today. The way this is going to work is I'm going to do all the slides today for the content for this week and next week. However, next week I'll be doing demos and talking about the exam. So then next week I'll be demonstrating this theory in class. Oh, there we go. There's one. Does somebody just try the door? I think it's when you open that door, door rattled. Wait, you can try the door.
I mean, they're all locked, so.
No, it's just the air. But just leave it. It's fine. All right. So today I'm going to talk about stored procedures, specifically when they're done in MySQL, functions, and I'll talk about the. Why is that not on? And I know I pressed the button earlier. Thanks. You didn't get very far. Slide 2. The first slide is the.
I just want to find this it's not happening, but it usually 45 minutes until I'm done.
Yeah, no, I think that's happened to me a few times. I hated it. Okay, so I'll be talking about stored procedures and functions and what's the difference between them. That's first. And then the second set of slides will be triggers. So the thing is that I do breeze through some of this fairly quickly because you guys by now should know what loops are, what conditionals are, what variables are. So I'm literally just going to talk to you guys about the differences between this and what you guys are used to working with. Okay, so starting with stored procedures. Stored procedures contain a series of SQL commands that are stored in the database so that can be invoked later by a program. They're precompiled, so they tend to be fairly fast to run. So you write a stored procedure, you put in all commands. When you apply that stored procedure, as in you save it, you actually create it, MySQL will precompile it and check for any syntax errors to make sure it will work. They behave like a script. So you guys know what a Python script is. You've got a series of commands at the top, and it basically reads the file from top to bottom, unless you're doing object-oriented whatever. But it's a script, like a bash script, a batch file on DOS, whatever. But they're SQL scripts. They do not return a value. So it runs and exits. Somebody else got to cut through. It includes many SQL statements such as select, insert, update, delete, basically DML. However, they do support input and output parameters. So you can feed it a variable going in and a variable coming out. So you can take the. So have you guys in Python? Man, it's been so long since I worked in Python. You know when you create a function and you have parameters on the function? Are you able to pass the parameters? If I remember, they only pass by value, not by reference. Other programming languages support passing variables in by reference, which means that the function can actually change the value outside itself, outside of scope. With this, you can have parameters, and you can mark them as input, output, or both. So the variable comes in, and the values get changed, and it outputs the variable at the end of right back out the same way it came in. So in theory, you can feed a stored procedure into another stored procedure by input-output parameters. It is able to call functions. It supports transactions. You can't use it in a join clause because you can't use it as part of a select statement. You call the stored procedure. You don't select star from whatever. All right, so the basic syntax is create procedure name. Shocker, it's like create table, create view, but it's a procedure. And then you have parameter specs, and you have n number of parameter specs. Then you have begin, you execute code, and you end. Now each parameter spec is in, out, the name, and the type. So it sounds like declaring a function. So in mode means allows you to pass the value in, out means passes value back out of it. All right, so I've got some examples that are kind of embedded in the slides, but next week I'll be doing actual real live ones. So picture we have two tables, employees and departments. the employee has a list of employees with salaries, and then the departments has a list of departments, and there's a DNO on the employee that shows the department number. So we want to keep track of the total salaries of employees working in each department. So we could create a table called department sal. So we're going to emulate a materialized view. We're going to create a table with a department number and a total, and it's all defaulting to 0. So now we got 3 tables in action. So we're going to write a store procedure that's going to update the salaries in that table. So the first thing you do when you write any kind of code in MySQL is you have to change the delimiter. So, where in SQL somebody goes select star from table semicolon? You have to change that. I know. Other database servers don't do this. In this, you have to change it. So you change it to something else. It can be anything else, as long as it's not a common character you'd have in your code. This example, we're going to use double slash. So essentially, first command is we're going to say, hey, ignore semicolons going forward. Do nothing until you see double slash. And I'm going to zoom in into it as much as I can. There, that's pretty good. So we changed the delimiter to 2 forward slashes. We issue a command called create procedure, give it a name, update salary, and then it has an in parameter, and it's an int. What it's going to do is the in parameter will accept the department number to update. And then you go begin. So begin is similar to the opening curly braces you'd have in JavaScript. Or in Python, your first tab. And then inside of that, you're going to write your store procedure. And in this case, it's just a chunk of SQL, update department salary, set the total salary equal to the sum, where the department number is equal to the parameter. And then end. With the semicolon, you'll notice there's semicolons inside the begin and the end. That's why we had to change the double slash, because if we have multiple statements in there, we need semicolons. But the problem would be is if we didn't change the delimiter, it would go create procedure, begin, blah, blah, blah. It would see the first semicolon and go, good, I'm done. I can run now. But the procedures are not even completed. So then you put in the double slashes, it runs the store's procedure creation, and it goes, okay. And then you change the delimiter back so that you're back in normal operating mode. Other database servers, such as Postgres, above the begin, you define a new delimiter. So it'd be like create procedure, whatever. Then you'd go like, say, $3 signs. Begin, blah, 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 and $3 signs. So that's how other database servers do it. Oracle does something similar. Okay? So now we can call the procedure, go call update salary 1, update salary 2, update salary 3, and it updates the salaries in each of these tables. So then we end up with, I still don't know why this green, every semester I fix that green box and it comes back. So you can see that, after running those 3 procedures, we updated all the departments. That's kind of okay, but then you still have to do it for every department. If you add a new department, you got to remember to update that one department. So I'll be showing you guys a better way to do it in a second. The show procedure, so like show table, remember last semester, show table, show databases. You can do show procedure status for some unknown reason, and it shows you the store procedures that are stored in your system. And to get rid of it, it's just drop. So drop procedure, give it a name, and the procedure goes away. So in a stored procedure, you can declare variables. You can use flow control statements, if then else. Or you guys probably know about do while or while do, depending on how you want to organize it. In MySQL's language, because of course every database server has its own stupid programming language. MySQL, it's while with repeat. Okay? While this, repeat these following commands. I mean, it makes sense. By the way, in case you're curious, the language for MySQL is called runtime. Oracle, it's called procedural SQL. In Postgres, it's Postgres, like PGSQL. Postgres SQL. Yeah. Microsoft SQL Server is really cool because it supports TSQL, Transact SQL. That's the original. It also does C#. Postgres, I'm kind of not, I'm under highlighting what Postgres can do because it does PGSQL, TCL, Perl, and Python by default as its stored procedures. As long as those are enabled, you can use any of those. And Perl and Python run in trusted and untrusted mode. So when it's in untrusted mode, you can actually modify files on a file system outside of the database through the database. So delete a record that holds a file name, it could reach out and delete the file off the disk for you. Very dangerous. So to get so anyways, back to the matter at hand. In MySQL, it supports something called cursors. Have you guys done any kind of Python to database work yet? Or C# to database?
What it was called, I can't remember, forgetting it was called Flask. Yeah, my last, literally last lesson in our Python class was
Flask.
databases, Flask, and then we just started, C# database stuff last week.
So in those, you establish a connection, you run a query, assign the results to a variable, then you loop through the results, right? You can do that inside of a stored procedure inside MySQL. It's called a cursor. So you loop through a cursor. The cursor basically moves through the records. They're all like that. PHP is the same way. So now there's a link in here that talks about MySQL tutorial, shows you stored procedures. So, to do the lab, that tutorial will help you get over that. So let's show you guys the exact same thing, but a stored procedure this time, but this time it'll use a cursor. So we're going to reset the department salaries table back to 0, just to be on the safe side. Now, a lot of code on screen all of a sudden compared to the previous example. Okay, so I'm going to update the delimiter this time to $$ because why not? Right? It's just to show you that it doesn't have to be double slashes. It can be pretty much anything you want. Just make sure it's unique. We create procedure update salary. If you look at what's on the screen now, you will notice there's no parameters anymore. We have our begin statement. And now we're going to declare a bunch of variables. And MySQL and Postgres, pretty much every database language is super anal retentive about where you declare your variables. You can't inline variables like you can in Python or PHP or JavaScript. You have to declare them at the start. And it's a good habit because that way they're all declared in one place. So we're going to declare a few different things. We're going to declare a variable called done, defaults to 0. Basically, it's going to be a Boolean, true, false. Basically done is set to 0 as in false at the beginning. We are going to declare another variable called current department number. It's an INT, no default value. Then we're going to declare a cursor. So declare, and we're going to call it denum curse, so denum cursor. And it's a type cursor for, and then you have your SQL statement that you're going to run. So you're going to declare a cursor for an SQL statement called select dnumber from department salary. So you're declaring, basically, it's as if you're doing it in Flask or in C# where you declare your SQL statement that you're going to run against the database. This time you're declaring it, but it's literally saying it's going to be a cursor. And then we get to the MySQL special part of this. Everything else so far is pretty much the same everywhere. Its syntax a little different, but the behavior is different. Same. With MySQL, you have to tell it what to do when it runs out of records. So in PHP or in Python, you can basically do a for each or a while, and as long as it's fetching records, it'll go, once it hits the end, it just returns false, and it breaks out of the loop. In MySQL, when you have a cursor, and you say, fetch the next record, and it hits no records, it gives you an error. So you put in an error handler called for declare continue handler for not found. So when you hit the end of the record set, what it's going to do is it's going to set the variable done equal to 1. So when you no longer have any more records, so you hit the end of the cursor, and it goes, oh crap, I'm out of data, it'll actually set the variable called done. It'll set it to true, to 1. And then you open the cursor. So that's when you basically execute your SQL statement against the database. And then we're going to do a repeat, so also known as a while. So then what we do first is we fetch the cursor into the current department number. And it's field for field. So if we only have one field, we can only populate one variable. If we had two fields, we could populate two variables at once. So we're going to fetch the cursor into that variable. We're going to update the department salary based on the denum. And then you'll see that repeat until done. So if done is 0, it's just keep repeating until done is not equal to 0, until done is equal to 1. And then you end the repeat. Always be a good citizen and close your cursor. And then end. So with this, if you were to take this and just basically convert it to JavaScript, you'd literally be declaring a handler. You'd be doing a while loop. You do some stuff inside the while loop. Once the while loop is complete, it bombs out. That's what this is doing. And how would it behave? Now, if we just to prove that department salaries are equal to 0, there it is. So then you can go update salary, no parameters, and it'll update all the salaries. The good thing about this one here is it no longer cares how many departments you have. One department, cool. 1,000 departments, also cool. It doesn't care. And there's another quick example to give people a raise. So it gives everybody a raise. So company had a great year, so it's going to give everybody a 3% raise, right? Less than inflation, but good year. Everybody gets a raise. Congrats. So this function, I did a delimiter. This time used a pipe. And you go create procedure, give raise, and you give it an in variable of amount. It's a double because, you want to give it a percentage. Begin, and you can clear, that would declare whether it's done or not. Employee ID, the salary, and then we declare a cursor for select ID and salary from employee. We add a continue handler because, again, MySQL does know how to handle the fact that it ran out of records. So you tell it, hey, this is what I want you to do when you run out of records. You open the query, you loop through it, and you can see in here that we're going to go fetch the employee record into EID and salary. So the fetch is feeding two variables because there's two columns in the query. So you got ID and salary here. So when you fetch the next record, it'll take this column, put it here, take this column, put it here. So you're populating two columns in one go. And then we're going to update the employee, set the salary equal to salary plus the rounding of the current salary times whatever the parameter coming in, where the employee ID is, whatever we pulled into the cursor. And then we do it until we're done, and then it ends. And you would just literally go call, give raise, 10% raise. That's a generous raise. 10% raise. So everybody got a raise. And it would just work. Okay, so those are stored procedures. Realistically, the only difference between stuff you guys have learned how to do already in your course and this is syntax. And it's one of those things that, just look at the reference guide for the syntax. Now I'm going to talk about functions. So functions, MySQL has lots of functions built in. You guys have probably played with some of them. Upper, lower, left. You got aggregate functions, like average, sum. Those are functions. Sometimes there isn't a function for what you want to do specifically. Let's say you want to create a function to randomly generate a token. You add a user to the database, and at the user insert, you want to generate a token automatically to add to their record. You could create a function that generates a token. Maybe you want to randomly pick a number between 1 and 20. And instead of using the rand function, you want to actually, use your own function. So based on creating your own functions, you extend the ability of your database. Functions are compiled at runtime, which means that every single time you call a function, it checks whether or not it's valid, which means there's a little bit extra cost. Not a lot, but it's there. Functions must have a return type, and it can only ever return one value. Just like a function in Python or function in C#, a function only ever returns one type. Maybe you can pass out an array, which is cool, but even that array is only one thing. It's only can be used in select statements. You can't use it as a call. It has input parameters, but no output parameters. So you have input parameters and a single result coming out of the function, just like in Python. Depending on what you're doing, they can't be used in transactions. A function can't call a store procedure, but joins are fine. And I'm actually just going to skip that so I can just go straight to this. And yeah, it looks like this went through the JPEG filter a million times. So here's a function to give a person a raise. Change our delimiter, create a function, give raise, old value, new value, returns a double. Now here's something that you guys don't have in Python or in C#. Well, maybe in C#, but definitely don't have this in Python. The next piece is deterministic or not deterministic. Deterministic means if the function gets called within a certain time window, I don't remember what the exact window was, like something like 10 seconds, and it receives the exact same parameters a second time. So you call the function and you feed 1, 2. A second later, you call the function passing in 1, 2 again. It won't execute the function this time. It's just going to return whatever the last result was. So it skips the contents of the function saying, you've already asked me this question. Therefore, why would I even think about doing the math? Here it is. You've already asked this. There you go. So that's deterministic. It means if you feed in the same parameters, it would always give you the same answer back without even looking at the code. If your code is actually doing some funky things to the database, you want to make it not deterministic. Then you go the typical begin, you got your declare, and in here we're setting a variable, the new value equal to the old value times 1 plus the amount, and it returns the new value. Literally, it's the same thing as you do in Python where you take one number multiplied by percentage, and it returns it. So the thing is, you could use this in a select statement. So you go select whatever. You can also use it in an update statement. So you could update employee set salary equal to give raise, and then you give it the current value and the percentage you'd use, kind of thing. So there's some pretty interesting things you could do with this. So there's the explanation of deterministic. I already explained it, so I'm going to skip the slide. So here's an example. Select name, comma salary, give raise, the salary column times 10% from employees, and you'd suddenly have a whatever. Now, if there's a null and it multiplies it, so what happens if you go null times 1? You get null, because you can't multiply null. Null will actually, it's one of those cool things, null will destroy whatever you try to connect to it. So if you try to multiply, add to a null, guess what? The answer is going to be null because the null ate everything else. Null always wins. So you've got to be careful with null. Okay, so now I'm going to talk about the difference between functions and stored procedures. A function is compiled at runtime. The stored procedure is pre-compiled, so it's a bit faster. The functions can only be used with select and update statements, basically DML. Store procedure supports absolutely everything else. The function returns only one value. Store procedure does not return anything, but it can output values through the parameters. A function behaves like a method or a function in Python. So if you know what a function is in Python, a function in SQL is the exact same idea. The store procedure acts like a script. One can be used in joins, one can't because you can't even use select with it. Functions, depending, I think this last line might be a lie now, but it used to be that you couldn't use functions in transactions. Store procedures can be used with a transaction as long as the transaction is inside the store procedure. But you can't put a transaction inside of a function. So you create a function, inside that function, you can't declare a transaction. But with a stored procedure, you can declare a transaction inside of it. So different use. So Unless you're just trying to generate numbers or do something minor, you usually want to use a store procedure um, because it allows much more complicated code, tends to be a lot faster. Um, if it's a simple task that you know repeat on a regular basis, you might want to use a function, or if it's something you need to use as part of the SQL statements, such as a select or an insert, then you want to do a function. Okay. So this set of slides just prepares you guys for this one. And the good news is this one's really short, not a lot of slides. We're going to talk about triggers, although there's not a lot of slides. The concepts behind it are really cool. And the concept is called triggers. Now, triggers are event-driven actions. You guys should know about this concept on click, on change, blur, focus, right? So those are events in JavaScript that fire off as you do things on the web page. In database servers, there are events. And all database servers that support triggers support at least 6 events. Some support more. And they are insert, update, and delete, before and after. So you can fire off a piece of code before. So you're doing an insert. You can fire off a chunk of code before the insert to modify the content of what's going in that insert. Or you could fire off a trigger after a record is deleted to make sure that there's cleanup or there's a log history that the delete succeeded. Depending on the database server, the trigger may not be part of the transaction. MySQL kind of doesn't handle triggers in a transaction. Postgres, Oracle, Microsoft SQL Server, they all do. So the events that drive the triggers, insert, update, delete. So as soon as the command is received, so what happens is you type in your command or you send a command to the database server looks at it and says, oh, it's an update. Now it goes and looks at the table involved and goes, hey, by the way, in this table, is there a trigger? And then it does some stuff. So we have, these are the 6 events that all trigger capable databases support. Before insert, after insert, before update, after update, before delete, and after delete. And they all have their own rules, for the most part. I don't know why that slide is double duplicated. Now, there's one other thing we need to be aware of when it comes to triggers, is there is certain pieces of data available inside the trigger. There's a chart somewhere, pretty sure it's included in here somewhere. The chart's after. So when triggers are being fired off, there's a certain order of events. And realistically, it's going to be almost impossible to read on the screen. I'm going to zoom in and move things around, but it's going to be hard to read on there. However, every single time a trigger fires off, there's 2 potential data structures that get created automatically for you. New and old. New is the new data being pushed in with, so when you insert, you're adding new data to the database. When you're updating, you're pushing new values to update a record. You'll get an object called new. This object has every field of that table, so it'll be new dot first name, new dot last name, new dot email. There's also old. What was there before? The old does not exist for whenever you do an insert. Because when you're inserting, there is no old data, right? Because you're only adding something completely new to the database. Just like new does not exist for delete, because when you're deleting something, you're not adding anything to the database, you're taking something else, so why would you create a new object? So the old record has the values that were there before the changes. And what's kind of nifty, and I'll pull up the chart now. All right, so this is the flow. What happens? And I'm going to zoom in and move around. Okay. SQL interpreter receives a command. It goes, is this a manipulation command? Insert, update, or delete? Yes or no? If it's no, in other words, a select statement, it just runs it. And, if it ran it, it just goes to the end of the whole thing. However, it goes, okay, no, this is an insert. Then it parses it to make sure, is it good? Yes, no. Then if it's no good, it gives you an error and it bombs out. Okay, it parsed successfully. Is there a before trigger? Now it goes, okay, we're dealing with employees and we're doing an insert. It goes, is there a before trigger? In other words, do I need to do something before I write the data to the database? If yes, it fires the trigger. If not, obviously it just does the insert. Now, at this point, you will have, since we're talking about an insert, we'll have a new variable available to us. We can actually change the values in the new object before we write it to the disk. And so, for example, we want to change the timestamps. We want to add a date, for example, to the record. We could go new.created equal to now. And they would actually add the timestamp in the database before it ever gets written to the disk. So then it executes a trigger. Did it succeed? Yes or no? If it fails, database server gives you an error. It executes the command. Then it goes, did it work? Yes or no? The usual. Then it goes, hey, now we've written the data to the database. Is there an after trigger? Yes, no. Okay, let's assume we also have an after trigger. After the insert, we're going to fire off a chunk of code. Now at this point, you can't change the values. Like you could assign new values to new, but they're never going to get written to the disk. So new is there for reference purposes in case you need to do an audit log. This was inserted here, so let's add something to the audit. And it executes the after trigger. And then it goes, did it work? Yes, no. If it did, congrats, return the results to the client. Otherwise, it goes to the error. Now, here's the kicker where MySQL is dangerous with triggers. In Postgres, for example, you go to do an insert. It fires the before trigger, does the insert, fires off the after trigger. If anything in all those steps fails in Postgres, the whole thing fails. The insert gets rolled back. In MySQL, the before trigger worked, the insert worked, the after trigger fails. Guess what? The record's still in the database. So yeah, with MySQL, you just have to be a little more careful with the whole database situation. Oh, that's not what I wanted. So with the update, let's talk about an update. Same thing. So it gets parsed. There's there a before trigger? Yes. Theoretically, now you have the new and the old. And I actually have an example of a trigger I wrote years ago. I just gotta go find it. I forgot to pull it up before class, so not sure if I'll find it before the end of class today. But essentially, we had somebody who was modifying the data in the database, and we didn't know why, how it was happening. So I wrote a before trigger and an after trigger. And in there, I was comparing new.serial number. If new.serial number not equal to old serial number, it would actually do, it would log the command that actually triggered. I could actually capture the update command to see what triggered it. So that way I could go through the source code of all the applications that talk to this database to find where the hell this command's coming from. And at the same time, if they did match, I would actually take the old value, insert it into another table so I could undo. So I'd have the history, this is the record that was modified, this is when it's modified, here's the old value. So even if it got modified 10 times, I'd have every version of it. There's a whole story type to that. I'll give you guys that story after this. So advantages of triggers. You can use it to catch more errors. Because in theory, the before triggers, you could actually double check certain rules that maybe the programmer of the front end didn't catch. You can use it to schedule tasks. I've done that. So we had a database that was running in a load balanced environment. So the front end server was running on 3 different nodes. talking to one database in the back end. We had a job that needed to be executed every day. The problem with this was that the three servers were identical. They were ephemeral. In other words, they could come and go as needed. So there's never a guarantee which one was going to be alive, because that's the point of a load balanced system. So what I did was I put in so we had, as part of the login process, it would it would update the user login with the last login date. And then I wrote an after trigger that said, hey, is this the first person to log in today? That was a little fancy, but and if it is, do these jobs. So it's scheduling jobs based on the first person to log in for the day. My person could go, man, that first login every day is really slow. I go, no, that's your imagination. No, dude, it was like running for like a good 30 seconds, the queries. But you can use that as a way of scheduling jobs by, after an update, go do this. You can use it for record keeping of table changes so they can be audited. A lot of accounting systems have triggers that automatically copy record tables. You can also use it for integrity checks and all kinds of fun stuff. However, triggers do have disadvantages, like everything else in the database. Just excuse me for a second. My eyes are screechy all of a sudden. Triggers have some disadvantages because it adds overhead, right? Every time you go to do an insert, you need to check if there's a trigger. If there is, it has to run it, which means for every insert, there's a chunk of code that runs, and you can have multiple triggers that run before insert. You can have like 3 or 4 triggers if you wanted that run before, and they just chain. And again, this is where different database servers behave differently. With Postgres, you can only ever have one before insert trigger, but you can use it to call functions. With MySQL, you can have multiple functions, and how does it decide which one it's going to run first? Anybody want to take a guess how it decides? Let's say you have 3 before insert triggers. How does it decide which one's going to run first? It's even dumber than that. No, that'd be the smart one. Alphabetically.
Oh gosh.
It goes A goes before B, goes before C, and you're not allowed to start your trigger names with a number. You could go trigger 1, trigger 2, trigger 3. But that's still terrible.
The actual trigger name or something, right?
But then suddenly you need to add a new trigger somewhere in the middle. How do you do it? Yeah, exactly.
You can do like 1, 1 or something. 1, 1, 1, 2, 1, 1.
Who knows? It could be really bad.
Yeah.
So it adds a bunch of resources every time they get called. And the thing is, it's triggered by the client side, but may not provide information for what's actually happening in the server. So it's a little more opaque. Okay, so there are limitations. However, as you can see, the slide only applies to MySQL. Triggers cannot execute the following statements. Can't do show, can't do load. You can't back up a database, you can't restore a database, you can't flush, you can't return, you can't set permissions with it. Okay? They can't be used in transactions or other statements that commit implicitly or explicitly. So the reason we say they can't be used in transactions is that they're not transaction safe. In other words, a trigger fires off, its data is actually outside of the transaction. So suddenly you're breaking the isolation of the transaction. So you just got to be careful. And a trigger in MySQL can't call another store procedure or function. So there's just some things you have to be careful with. All right, so what does it look like when you create a trigger? Actual fact, I don't need to find the code. I now remembered that I updated these slides to actually use that exact example. Just translated so that it's MySQL instead of Postgres. All right, so delimiter $$. Does this sounding familiar? Create trigger, you give it a name. Then you tell it when it fires off. So create trigger, product serial number log, after update, on, in this case, the table called products, for each row. Now, this one's an interesting piece of syntax. So when you create a trigger, there's 2 flavors of a trigger. There is a global trigger and or a per data row trigger. So when you go for each row, what that means is if you do an update statement, you go update password expiry, and you just don't even get a where clause, so it affects every row. When you use for each row, it means for every row being affected by the insert, update, or delete, it will fire this trigger. If you do not include for each row, it'll fire once for the entire statement. So for each row means for every row you're affecting, it will run this trigger. If you do not have for each row, it means it'll do it for the whole transaction. So you could be inserting 1,000 rows, but it'll only ever fire the trigger off once before it tries to do all the inserts. Just different, usage patterns. Then you go begin, and here it is. If old serial number is not equal to new serial number, then. And this one makes a lot of people hurt when they read this syntax, except for those of us of a certain vintage. They decided to model the if statement on BASIC, the language called BASIC. Way back in the day, that's what we learned as our first language in school was BASIC. So for me, this looks really familiar. So you go if old not equal to new, then. Now I'm doing an insert into product log. So essentially, the record was updated. It was written to the disk. After that succeeds, it'll actually create a log entry showing old ID, new ID, when was it updated, and a little note. End if and end. So every single time a serial number would have been changed in the products table, it would create a log so we had a history of what the serial numbers were. This interesting thing about this particular system that this was tied to, and this is not quite what they did more, but that's a simplified version of it, was those serial numbers could change because those were hardware IDs. So we generated an ID of the person's hardware. So let's say you suddenly change your GPU, your hardware ID would change. So so the person would reactivate their software, and we get a new ID, and we'd update their record with this. So then we kept track of what their hardware was. Yeah. Now with a trigger, you can cause the trigger to error out. So let's say you don't want to let somebody do something. You can actually trigger an actual error. So dilemma $, create trigger, products log before delete. In other words, you don't want to allow anybody to delete records out of the product log, because then what's the point of having a log of all the serial numbers if somebody can just go in and delete the records? So you create a function, or a trigger. So before the delete, for each row, so in other words, you try to delete 10 rows, for each row, it's going to do this. Begin, signal SQL state. 45,000, don't ask me why, but that's what it is. It's the error. So signal means send a message back to the server and the client. SQL state, 45,000. So it's like for web development, 404, page not found. With 45,000, it's error. Like literally, it's a fatal error. Then you give it a message. Set the message text equal to, you give it a string. In this case, I'm like, no deleting logs. End and delimiter. So every single time you try to delete a record, it'll tell you, yeah, no, you're not allowed to do this. So yeah, so that's triggers. Like I said before, the only difference between what you guys have been doing in your other classes and this is syntax. Conceptually, it's very similar. You got variables, you got loops, you got functions, you've got, it's just building the part of the beginning at the end that's a little different. If you're trying to write a trigger and you're not sure how to write it, think about how you'd write it in another language and then you just translate it. I love triggers. They're a fantastic tool. Current job, I don't use them very much because I don't do a lot of development, but my old job, holy cow. Our primary database must have had something like 300 or 400 triggers in it. There's triggers for everything. Yeah.
How many SQL states do we have?
How many states?
45,000.
45,000. Oh man, that's a good question. Actually, you're the first person I think that's ever asked me that. MySQL signal state codes. Um, 0, 1, 2, 3, 2, 2, and 45,000. Let me actually go to the actual proper documentation from MySQL. No, that was a summarized one. Hang on, where are all the codes? You'd think they'd give me the list of signal states. Hang on, somewhere in here. Signal, get diagnostic statement, signal overview, condition information items. So 0 is success, 1 is warning, 2 is not found, 2 can also be exception. Apparently, there's a 40. You just dig through the documentation until we find. Honestly, I don't know how many there are. Like the database server I worked with, we had very specific, like there wasn't numbers. You raised a specific error code. Interesting. That's a good question, and you're the first one that's ever asked it, and I've never. That's the signal statement. Let's go take a look at that. Is it going to be listed in here? No. Listed in here? Apparently, that's it. So 40 is a generic exception, 45,000 is a fatal exception. So, but realistically, the only one you'll ever use is 45,000. Okay. So yeah, so that brings us to the end of today. And officially the end of the content for the semester. Yay. Next week, I will be going over the exam, rules of engagement for the exam and stuff. That'll be the typical thing I do, which I just tell you what the question breakdowns are. Which is the easiest. Since I record my lectures, I don't see the point of doing formal reviews, right? Why would I want to go through, 150 slides in an hour? Like this one's important, this one's not important, this one's important, this one's not important. That's just gross.
You just put a seal on the slides at the beginning of the semester. That way we can know just about the slide and we should pay attention.
Yeah, no, I want you to read the whole slide. So I'll give you guys the number of questions of each type. We'll go over the rules of engagement. Then I'm going to sit down and run through an example of a set of triggers. And probably an example of functions too. The triggers themselves, just so you know, it's an inventory allocation system. I'll explain what that is to you guys when I talk about the triggers, but it's an interesting concept to do. Normally, nowadays, you don't do it in the database, but back in the day, we'd do it right in the database. And I'll also pull up a few examples of some functions that you can, get MySQL to roll dice for you. You want to do 3D20s, you can get it to do it. Write a function to roll a 3D20 or a 2D12 as needed. So yeah, that's what's happening next week. The last class, I have no content and everything will be done. So I have to come to school. I will be here. If you guys need a classroom, cool. If you're not here, I leave after 15 minutes. So, but I will be here, but there's no content. So I can't say class canceled, but.
Next week, I'll be.
Yeah, well, yeah, definitely next week, yes. The week after, whatever.